Good morning, students. Today we are going to learn about the resistors in series. An electric circuit may contain a number of resistors which can be connected in different ways. Now let's see the resistors in series. I am going to connect three resistors in series. And I am going to name them as R1, R2 and R3. Can you see how these resistors are connected? One end of the resistor is connected to the other end of the resistor. Now I am going to connect the three resistors to a battery which supplies a potential difference V. The long line is the positive terminal, the short line is the negative terminal. Now IB, the current flows from the positive terminal. Now see the direction of the flow of current. Since one end of the resistor is connected to the other end of the resistor, the direction of flow of current will be the same throughout all the resistors. There won't be any accumulation of charges. When we want to find the equivalent value of three resistors, instead of three resistors, we can have one resistor which is equivalent to three resistors connected in series. We can consider it as Rs and V be the potential difference and I be the current flowing in this direction. Since all the resistors are connected in series, the same amount of current flows across all the three resistors. But the value of resistors are different. So the potential difference across all the three resistors will be different. Now V1 be the potential difference across R1, V2 be the potential difference across R2 and V3 be the potential difference across R3. So the total potential across all the three resistors will be V1 plus V2 plus V3. According to Ohm's law, V is equal to IR. The potential difference across R1 will be IR1 and potential difference across R2 be IR2 and the potential difference across V3 be IR3. Now we can substitute all this in this equation 1. We can substitute all this in equation 1. V is equal to IR, which is equal to IR1 plus IR2 plus IR3. Taking I as common, R1 plus R2 plus R3. Now I gets cancelled on both sides. So R is equal to R1 plus R2 plus R3. Now Rs be the equivalent resistance of three resistors. So when resistors are connected in series, the equivalent resistance of all the three resistors will be R1 plus R2 plus R3. So Rs will be equal to the sum of the three individual resistors. Now let's say that we have the value of R1 be 5 ohms and the value of R2 be 6 ohms and the value of R3 be 2 ohms. So what will be the total resistance will be? It will be 5 ohms plus 6 ohms plus 2 ohms, which will be equal to 13 ohms. I conclude that the value of equivalent resistance in series combination will be sum of the individual resistors. And I also say that the equivalent resistance in series combination will be greater than R1, R2 or R3.